Today, let's look at hypothesis testing, but with proportions. The following question reads, the historical percentage of business executives in a European country with an MBA qualification is 32%. But this has not been looked at for a while. A sample of 240 executives is asked about their education. 96 of them have an MBA. Conduct a suitable test of proportion at the 95% level to determine whether the survey gives evidence that the current percentage of MBA holders is different to the historical one. Okay, so the first thing to do, as always with hypothesis testing, is to state the null and alternative hypotheses. The null hypothesis for hypothesis testing with proportions is going to be a proportion. So we write it as P. So P is equal, and in this case, the null hypothesis is that 32% have an MBA qualification. Therefore, the proportion, which is the percentage divided by 100, in this case is 0.32. And on the other hand, the alternative hypothesis, in this case, because it says that we need to give evidence on whether it's different to the historical one, different being the key word, means that the alternative hypothesis is that the proportion is different to 0.32. So it can either be higher or lower. So given this information, here's a question for you. Do you think this is going to be a one-tailed test or a two-tailed test? Now this is indeed going to be a two-tailed test, okay? And that's because the alternative hypothesis says it has to be different from 0.32. So it can either be higher or lower, meaning that we're going to have a rejection region on the right hand side and one on the left hand side. Okay. The confidence level is 95% in this case, which means that the area that isn't shaded is 0.95. Then the significance level is going to be whatever's left, so in this case 5%. And because this is a two-tailed test, we need to split it into two. So 5% divided by 2, in this case is 2.5%. So we have a significance level of 2.5% on each side. Okay. Now the next thing to do is to find the critical value. The critical value is the value at which the shaded regions start, okay? And it's going to allow us to decide if we reject the Z value we get or not. Now, in order to find this critical value, we need to look at the table, the Z table. What we need to do is we need to find the significance level, so the 0.025, inside this table. Now, in this case, it happens to be right here. So as you can see, 0.025. Then what we need to do is go horizontally and vertically in order to form the critical value. Going horizontally first, we get minus or plus 1.9, and then the decimal places is 0.06. Therefore, our critical value is plus or minus, because we can use this either for plus or minus, 1.96. Okay? Now, if you want to go into more detail, you take 1.9 and then you do plus the decimal place, which is 0.06. Okay? And this gives you 1.96 plus or minus. Therefore, we go back and we write the critical value, which is 1.96 on the right hand side minus 1.96 on the left hand side. Excellent. Now all that's left to do is to get the Z value. Okay? Now first let's write down what we know. So as you can see, because this is hypothesis testing with proportions, we have some extra elements. So the first one is P naught. This is the hypothesized proportion. So in this case, it simply is the proportion stated in the question. So 0.32, okay? Then the sample proportion is going to be X, so in this case 96, because they're the ones that have an MBA, over the total sample size, which in this case is 240. And this should give you 0.4. So this is the sample proportion. Then we also need Q naught. Now as you can see, Q naught is equal to 1 minus P naught. So Q naught, 1 minus P naught, which is 0.32. And this gives us 0.68. And finally, the only thing left to find is the sample size, which we know from the question is 240. Okay, excellent. So as you can see, we have everything we need to use this formula. Therefore, the Z value is going to be the sample proportion, 0.4, minus the hypothesized proportion, 0.32, over the square root of P naught times Q naught, so 0.32 times Q naught, 0.68, over the sample size, which is 240. Now if you plug this into your calculator, I've already done the calculation, not to waste time, and this should give you 1.24. 1.24. So going back to our graph, as you can see, 1.24 is not in the shaded region, or also known as the rejection region. So let's say it's somewhere around here. So because it's not in the rejection region, which is the shaded area, this means that we fail to reject the null hypotheses. And this is it for this exercise. Now let me know if this makes sense. Otherwise, put any questions you have in the comments and I'll be happy to answer them.